Hello everyone. Today we'll be doing the part 5 of Fundamentals of Economics. Let's understand what is economic analysis. Because in economic analysis we'll be using the tools to analyze the economy, and today's topic is tools of economic analysis. To understand the tools of economic analysis, to understand the importance of the tools of economic analysis, it is important to understand what is economic analysis. So economic analysis is a systematic process which helps determine the optimum use of limited resources. It helps compare the available alternative, and it helps to choose the best alternative in order to achieve a particular goal or objective. It even helps in determining the strengths and the weakness of the economy, and it also helps in determining the causes of the economic problem. So this is the meaning of economic analysis. So economic analysis helps us in understanding the use of limited resources. So we are analyzing and figuring out what is the use of the scarce resources. Let's take an example of a resource like gold. So if we have taken the example of gold, then first in economic analysis, it helps determine the optimum use of the limited resource gold. First, they'll analyze what all this gold can be used for. Okay, first that is done. The next thing that is done is the comparison is done between the various alternatives that is available. Well, there'll be a lot of there'll be a lot of alternatives available for the use of gold. So we need to understand where we are going to, like which alternative we need to choose, like in which particular alternative we are going to, make a lot of profit, or in which alternative we need to invest. So all this decision has to be made. For that, comparison of the alternatives is must. So then again, this comparison happens. And then after that, the best alternative is chosen in order to achieve the objective. In this case, in the case of an example, the objective is to have maximum profit. So keeping that objective in mind, an economic analysis was done with regard to the scarce resource gold. And then a lot of alternatives was found out. With respect to gold, like different ways in which gold can be used. And then after thorough analysis, the best alternative was chosen, keeping in mind the objective of profit. So this is how economic analysis is done. I just gave an example of how it is performed, just to understand. Now, to do this economic analysis, there are four tools. There are four common tools which helps us perform the economic analysis. Now we understood how economic analysis is done, and this is the reason why we're doing this, because it helps us understand the strengths and weakness of the economy. It helps us find out the causes of various economic problems. That's why we're doing it. So to do it, we require certain tools that will help us do it. The first tool is called as economic variables. Second one is slope. Third one is optimization techniques, and the fourth one is linear programming. So with the use of these tools of economic analysis is done. Let's understand the first tool of economic analysis, that is economic variables. Economic variables refers to any economic quantity whose value changes with the change in its determinants. Let's understand all these terms with an example. We know that with an increase in price, the demand reduces, right? The increase in price, demand reduces. With the decrease in price, demand increases. So we are aware of this fact. Now, when this scenario is happening, demand is dependent on price. With every increase in price, demand is falling. With every decrease in price, demand is increasing. So this variable, that is demand, is dependent on price. So price is the independent variable, and demand is the dependent variable in this example. Dependent variable in this example. So independent variable refers to variables that are independent and are not affected by a change in any other variable. They are not affected by change in any other variable. They are independent. And dependent variable refers to those variables whose values are dependent on the values of other variables like demand. In this case, demand. So demand is a dependent variable and price is an independent variable. Now let's understand what is endogenous variables. Endogenous variables refers to variables whose value can be obtained within the model under consideration. Whose value can be obtained within the model under consideration. Let's take an example. The price of a product in the supply and the demand model is said to be endogenous. The price of a product in the supply and demand model. In case of the supply and demand model, the price is said to be endogenous. Why is the price said to be endogenous in this model? Because price of the product is set in response to the consumer demand. This is the price is set because the price is set with respect to the consumer demand and is part of the model itself. That is part of the model itself. That's why price is said to be an endogenous variable in this case. Now let's understand what is exogenous variables. Exogenous variables refers to variables whose values obtained outside the model under consideration. Like previously how we saw in case of endogenous variable, price was part of the model. Price was part of the supply and demand model. That's why we found out the value of price through that model itself. Thus, price became an endogenous variables. But in case of exogenous variable, we cannot obtain the value within the model. We cannot obtain the value of that particular variable within the model. The value is obtained outside the model under consideration. The value is obtained outside the model under consideration. Let's take an example. In case of an increase in domestic oil prices, in case of increase in the domestic oil prices, due to an increase in international oil prices, the international oil price is the exogenous variable. The international oil price is an exogenous variable. It is not part of the supply and demand model. So this international oil price, this particular variable will be called as an exogenous variable as it is not part of the supply and demand model. But since price is a part of this model, that becomes an endogenous variable. Since international oil price is not a part of this model, that becomes an exogenous variable. The second tool of economic analysis is slope. So let's understand what a slope is. We have seen slope in graphs. So that is something that we are familiar with. In graphs, we see slope. Let me just draw. This is a slope. This is a slope. This is referred to as a slope. In simple terms, so visual understanding, this is called as slope. So now what is slope? It is something that's represented on a graph as a straight line. Slope can be positive or it can be negative. Slope helps to determine the changes produced in one variable with respect to the change in another variable. That means whenever there's a change in the independent variable, some change occurs in the dependent variable. That change that is happening in the dependent variable is referred to as the slope. That change that is happening in the dependent variable is referred to as the slope. For example, and in slope we have two types, like how I told, there is positive slope and there is negative slope. So what kind of slope is this? Is this positive slope or is it negative slope? The meaning of positive slope is there is an upward movement. Meaning of negative slope is downward movement. So here what kind of movement do we observe? Here we see that initially it is over here, then slowly it is coming down, 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 down. So this is a downward movement. This is a negative slope. This is a negative slope. Let's see what a positive slope looks like. Positive slope will be going upwards. The movement will be upwards. So this will be the positive slope, which will have an upward movement. It will be a straight line with an upward movement. So this is an example of positive slope which moves upwards from the starting point. We start seeing from the beginning point. So this is the point at which you are starting. So from the starting point, it's moved upwards. So here, which is the starting point? This is the starting point. From the starting point is coming down. So this is downwards. This is a downward slope. This is an upward slope. And slope can also be understood as the change in y with respect to the change in y with respect to the change in x. Here y is the dependent variable and x is the independent variable. Let me take an example to clear this. For example, let's say there are 10, 10 mangoes. Okay, let's say there are 10 mangoes. Price of which is some 10 rupees. Okay, 10 mangoes, 10 rupees. Later, what happened? There was a change in price. The price came down to 5 rupees. When the price came down to 5 rupees, the demand increased, it became 20. The demand increased. Now 20 mangoes are being demanded. That means with a decrease in price, as price decreased, demand increased. As price decreased, demand increased in this case. So this is what we saw here. Now, by using the formula that we just read, the formula said that change in the dependent variable. What is the dependent variable in these two? Dependent variable is the demand. This is the dependent variable. That's the demand. So dependent variable change is 10. That is the difference between both. That is 10. And the difference between the independent variable is difference between an independent variable is 10 minus 5. That is 5. So the answer will be minus 2. It will be a minus, so the answer will be minus 2. So this is the slope. Minus represents the negative slope, and 2 is the measurement of the slope. The slope is 2. So this 2 is showing the change that has occurred in the dependent variable, with the change that happened in the independent variable. That's what this is showing. The sign here, if it was plus, it would have determined a positive slope. If it is minus, it determines a negative slope. Now let's understand the third tool of economic analysis, which is called as the optimization techniques. These are techniques that are used to determine the value of the independent variable. That in turn either maximizes by maximizing or minimizing the value of the dependent variable. And these optimization techniques, they play a huge role in managerial decision making. Let's take an example. Let's say there's a manager, and that manager wants to determine the level of output. He wants to determine the level of output at which the cost is minimum. Okay, cost is, I'll write it as MIN to understand. Okay, the cost is minimum, and the output should be such that the profit is maximum. The output should be such that the profit is maximum. So in this case, the manager is wanting the value of the output, and the value of the output is the independent variable. So the manager wants to determine the value of this independent variable called the output, and he does this by maximizing or minimizing the value of the dependent variable. He minimizes the value of the cost, or he'll maximize the value of the profit. So in this case, cost and profit, these two are the dependent variables. So you can either minimize the cost or you can maximize the profit. So these are techniques used to determine the value of the independent variable, that in turn either maximizes or minimizes the value of the dependent variable. By maximizing profit, you will find out what the output is. By minimizing the cost, you'll find out what the output is. This is called as the optimization technique, in which you're finding out the value of the independent variable by either maximizing the dependent variable or by minimizing the dependent variable. The last tool is linear programming. Linear programming is a mathematical technique that is used for solving optimization problems for the business. It not just helps in solving the optimization problem, but it also helps in the allocation of resources. There are some assumptions in case of linear programming, which are linearity, continuity, proportionality, constant price, independence, and additivity. Constant price assumes that the prices of the input and the output remain constant regardless of the quantity that is purchased and sold. So constant price is assuming that the prices of all the inputs in the linear programming and all the outputs of the linear programming, they are the prices of that is constant. For example, if a raw material, let's say coal is a raw material, then the value, and that's an input. Raw material is an input. If that is a raw material, then its price will be constant. And the output's price, let's say the output is electricity. So the output price, if it is 50 rupees, that would remain 50 rupees. So price is remaining constant. There is no change in the price. So the price is remaining constant of the inputs as well as outputs. The next assumption is proportionality. Proportionality assumes that there's a proportional relationship among variables. There's a proportional relationship among variables. The proportionality between the variables remains same while finding out the solution of the problem. That means if previously there was one output is equal to five inputs, that means out of five inputs, if you're able to create one output, and the ratio is like 1 is to 5, and then later on it might increase to 10 output created out of 50 inputs. Again the ratio is 1 is to 5. Previously it was 1 output for 5 inputs, now it is 10 output for 50 inputs. The ratio of both is 1 is to 5. That's what is the assumption of proportionality. The proportion doesn't change, though the output and the input varies. So, as per proportionality, this assumes that there is a proportional relationship among variables. The proportionality between the variables remains same while finding out the solution of the problem. This implies that the proportional relationship among variables is same at every level of output. At every level of output, the proportional relationship is the same between the variables. The next assumption is independence and additivity. This assumption assumes that variables and the numerical values are not dependent on other variables. They are independent. Variables and the numerical values are independent. This implies that variables are selected randomly within limits. So the variables are not dependent on any other variables, and they're randomly selected, and they all are independent. So all the variables are independent. Another assumption is that it is additive in nature. That is, another assumption is related to the additive nature of the variables. That is, they can be added together. If the variables cannot be added, they cannot be solved under the linear programming. They should be additive in nature. It should be possible to add them. The next assumption is continuity. This assumption assumes that all variables are measurable only if they're having a numerical value. And the last assumption is linearity. This assumption assumes that a linear relationship exists between the input and output of production. Linearity assumes that there is a linear relationship existing between the input and the output. Thank you so much for watching the video. Please do like and subscribe. Thank you.